Okay, so in today's video, I'll be discussing how to solve exponential equations using logarithms, and I will go through 6 different examples, and they will all range in difficulty. So we're just going to start off with one-step equations, and then 2 to 3 steps, and then I'll just proceed from there. So we're just going to start off with a pretty simple exponential equation where we just have to solve using a log. So our first example is going to be 3 to the power of b is equal to 17. And how would you say we solve this? What log should we take? Well, it doesn't really matter what log we take because we are always going to get the same solution. So just to show the example, we could take the log of 10 or just the log of 3 and have log 17. And if we just divide by log of 3, we have b is equal to log of 17 divided by log of 3. And that could be a tedious step that you don't want to take. Rather, you want to go ahead and just take the log of the base that holds the variable as the exponent. So here we just see that it is 3, so we just take the log of 3. And then as we see that they have the same base and the same inside, we can go ahead and just have this cancel out because it's just going to be 1. And here we have b is equal to the log 3 of 17, which is the same thing as that. So that's just to help you be able to solve those types of exponential equations rather quickly than having to take the natural log or regular log. Unless you're asked to take the natural log, then go ahead and do it. But let's go ahead and look at one more example before we go into a much more difficult one. So we're going to have 20r is equal to 56. Let's just take the log of the base with the variable as its exponent. And here we see that 20 has r as its exponent, so we just take the log of 20. Log 20 of 20 r is equal to 56, or log 20 of 56. And here we also get that r is just equal to log 20 of 56. So they're pretty simple to solve. Just take the log of the base that has the exponent as its variable. Now we're going to look at a pretty more complex equation. So we have 5 times 18 to the power of 6x is equal to 26. What should we do here? What do you think is the best choice? Well, we're going to go ahead and divide the entire equation by 5 to get rid of the 5 that is on the left-hand side. And by doing so, we're going to get 18 to the power of 6x is equal to 26 over 5. And we can do the same step we did in the previous 2 examples since we have 6x as the exponent. So we're going to go ahead and do that. So we just have 6x is equal to a log 18 of 26 divided by 5. And we can expand this, but we'll leave it like that. And just to get x, we just divide by 6, giving us log 18 of 26 divided by 5 all divided by 6. So that is the solution to our exponential equation. And we're going to go ahead and look at one more before we get into another example. So here we have e to the power of x minus 1 minus 5 is equal to 5. So here we are dealing with e, so that means we're going to be dealing with the natural log, or with whatever log we want, but it is logical to use the natural log. So first, let's just go ahead and add 5 to both sides, giving us e to the x minus 1 is equal to 10. So we just subtract or added 5 to both sides, giving us this equation, and it is equal to 10. And we just take the natural log, giving us x minus 1 is equal to the natural log of 10. And with that, we just get that x is equal to the natural log of 10 plus 1. So let's go ahead and look at the final two examples. So here we are going to have 3.4 e to the power of 2 minus 2n minus 9 is equal to negative 4. So here we can go ahead and just add 9. So we have 3.4 times e to the 2 minus 2n, and that is going to equal positive 5 because 9 minus 4 is positive 5. And here we can divide by 3.4, giving us e to the 2 minus 2n is equal to 5 divided by 3.4. Now we can take the natural log, giving us 2 minus 2n is equal to the natural log of 5 over 3.4. And we are going to go ahead and subtract 2 from both sides, giving us negative 2n is equal to the natural log of 5 over 3.4 minus 2. Dividing by negative 2 to get n, we end up with n is equal to negative the natural log of 5 over 3.4 minus 2 divided by 2. And that is the solution to our equation. And the final example we're going to look at is 6e minus, or to the power of negative 4k minus 10 minus 4 is equal to 63. So here we can go ahead and subtract 4 first. So we get 6e to the power of 4k minus 10 is equal to 67. Dividing by 6, we also get e to the power of negative 4k minus 10 is equal to 67 over 6. Taking the natural log, we get negative 4k minus 10 is equal to the natural log of 67 over 6. And now we can just go ahead and solve this two-step equation. And by doing so, we're going to get that k is equal to the natural log of 67 over 6 plus 10 divided by 4, or negative 4. And that is our solution to our equation that we had. So, as we see, solving exponential equations that require logs aren't too difficult, since all we're doing is just getting rid of the base so that we have to solve for our variable, which is commonly referred to as x. But you're always going to see x in terms of k, a, b, v, u, or any letter in general. And you just have to solve for it once you have gotten rid of the base, like in this example, e. Getting rid of e by taking the natural log, we just had to solve for k. So I hope you enjoyed this video and that you understood everything in the video. And I hope that you have a wonderful day. Thanks for watching.